In this video, you're going to learn about some of the basic probability rules. But before we do that, let's review how to find a probability. It's the number of favorable outcomes over the total number of possible outcomes. So here we have a probability statement. We read this, the probability of red. And so we notice that there are 2 reds out of 12 marbles. So the probability of choosing a red is 2 out of 12. And then we can go ahead and simplify that by dividing both the top and bottom by 2. We often express probabilities as decimals, so we can divide 1 divided by 6 on a calculator. And when we do that, we get a repeating decimal. So I'll just go ahead and round that off to 0.167. And so the probability of red, we could say, is 1 out of 6, or 0.167. Now, it doesn't make sense to have probabilities less than 0 or greater than 1, because if the probability is 0, that means it never happens. And if the probability is 1, that means it always happens. Notice if we convert the number 1 into a percentage, well, 1 equals 100%. So if the probability is 1, it happens 100% of the time. So to summarize that, for any event A, the probability of A is in between 0 and 1, including 0 and 1. In this example here, we're looking at the possible outcomes when we roll a 6-sided die. Now, the probability of getting a 7 when we roll one die, well, we can't get a 7, so we say the probability equals 0. Now, the probability of rolling a number less than 7, well, that's always going to happen because all of these outcomes are less than 7. So the probability of rolling a number less than 7 equals 1, because that always happens. And then probabilities that sometimes happen will be in between 0 and 1. We also know that the sum of the probabilities must equal 1. So in this example here, we have a big pile of M&Ms, and we have probabilities for all of the colors of M&Ms except for blue. Now, since these probabilities all have to add up to 1, we can use that idea to figure out the probability of choosing a blue marble. So if x is the probability of choosing a blue marble, we can say x plus 0.20 plus 0.16 plus 0.14 plus 0.13 plus another 0.13. All that has to equal 1 according to this probability rule. When I add these up, we get 0.76. And remember, x is the probability of getting blue. So to figure out the probability of blue, we can just subtract 0.76. So we get the probability of choosing a blue marble equals 0.24. So to write our equation, we use the idea that the sum of all the probabilities must equal 1. Closely related to that idea is the complement rule. The probability of not having something happen equals 1 minus the probability that it does happen. So in this case, to find the probability of not choosing a red marble, well, we could do 1 minus the probability that we do choose a red marble. So that would be 1 minus 2/12. Now 1 is the same as 12 over 12. So we have 12/12 minus 2/12, which equals 10/12. And we can divide both of those by 2, giving us a probability of not choosing a red marble of 5/6. You'll be learning more about general addition rules later, but for now, let's discuss the addition rule for disjoint events. Disjoint events are events that never happen at the same time. And the addition rule for disjoint events is that the probability of A or B happening equals the probability of A happening plus the probability of B happening. But this only works when A and B never happen at the same time. We'll talk more about that later. So in this case, the probability of getting either a 3 or a 5 when we roll a 6-sided die, well, that would equal the probability of getting a 3 plus the probability of getting a 5. Now, the probability of getting a 3 is 1 out of 6, and the probability of rolling a 5 is also 1 out of 6. And adding those, we get 2 6. And we're dividing both of those by 2, we get 1/3. So the probability of rolling either a 3 or a 5 is equal to 1/3. Now later you'll be learning about a general multiplication rule, but for now, let's discuss the multiplication rule for independent events. Now, independent events are events that don't affect each other. And when we have independent events, the probability of both A and B happening equals the probability of A happening times the probability of B happening. So notice the difference here. In this multiplication rule, it's an AND probability. And in the addition rule, it was an OR probability. So in general, when we're finding an OR probability, we're adding. And when we're finding an AND probability, we're multiplying. So here's an example. If you roll 2 dice, what is the probability of getting a 4 on both dice? So to calculate the probability of getting a 4 and a 4, that would be the probability of rolling a 4 on the first die multiplied by the probability of rolling a 4 on the second die. Now, we're allowed to do this because what we get on the first die doesn't affect what we get on the second die. They're independent. All right, well, the probability of rolling a 4 is 1 out of 6. And the same thing on the second die. And when we multiply two fractions, we multiply across the top and across the bottom. So the probability of getting 2 4s equals 1 out of 36. I hope this video about some of the basic probability rules has been helpful. This is Mr. Ela, signing off.